I'm working on restoring this Delta drill press from 1942. The next thing to tackle is this crusty old motor. Getting this pulley off the motor is proving to be a challenge. The keyway is misaligned, so I'm guessing it's all just buggered up inside there. I've got it pretty well supported and just kind of trying to tap it out, slowly going. I'm probably not going to reuse this pulley, but I'd rather not break it. This isn't the original motor, but it looks about right. But it has a 5-step pulley on it. It should have a 4-step pulley. I went ahead and tore the motor apart because I knew that there were some bearing issues with it. And what I hadn't considered was that these are actually plain bearings, not ball bearings. It's got the little oil cup here, which is fine when the motor's sitting in this orientation and the oil runs down into the bearing. But when it's upright on the top bearing, it basically just runs out the bottom, doesn't actually get into the bearing. You can see even after I cleaned it up, there's some scoring on this shaft. Bottom end looks fine though. I'm going to see if I can pull this apart without destroying it too much. Managed to get that apart with that. This is the steel bushing that's acting as a bearing. It's pretty chewed up inside. There's a whole bunch of packing in here. This is all clogged up in here. I don't know if this is packing or just crud. Looks like some of each. I'll partially retract my previous statement. There's a lot of effort and this packing material put into trying to get the oil to wick around where it needs to go. I think I'm going to go throw this in the evaporust and think about how I want to fix this. So I'm missing the cover that goes on here, and I also don't have anywhere to put the switch. The original motor had the switch mounted on the motor. I want to do something lower profile than what was on there before. So what I'm thinking is cast something like this, and then mount the switch right there. While I'm at it, I'm also going to cast a blank for the replacement for the motor pulley. Those came out good enough to work for what I need. Got a little bit of cleanup I need to do on it. So kind of an interesting casting defect on this one. It didn't really fill in here. I think there's some shrinkage, or maybe it was because this was sitting upright in the flask. Steam got up in there and kind of pushed it out, but it got really thin there, and I broke through there. This wall thickness actually isn't quite thick enough anyway right there. So let's try another one. So this one came out better. Final result. Hole did try to sneak out there a little bit, deflect it out, but it should be okay. I soldered the wires onto the leads and shrink wrapped them, keep it all insulated well. Of course, being a motor from the 40s, there's nowhere to attach that ground. Welcome to the 21st century, little buddy. While I'm here, I might as well replace the start capacitor. I guess the technology for these has gotten a little bit better. It's the same capacity, same diameter, just a lot shorter. Of course, I had to take this apart to get this thing jammed in there. Now that that's done, it's time to go after the elephant in the room, which is this bearing. Dug around, found an oilite bearing that's the right size for this, but it turns out there's enough wear on that it's about 1/1000th and a half under. Yeah, about 1/1000th and a half under, which for those of you who want it in metric, that's about too much. That shaft's also really chewed up and pitted, and trying to polish it didn't really do much, so I don't think that's going to work. I could turn the whole shaft down, clean it up, and then just make a custom bushing out of this for there. Especially because I'm going to be doing another pulley for it. I could make one with the same size hole in it. It's not a bad option, but I think what I'm going to do is go to some ball bearings on this. I'm going to have to bore this out and press these onto there. but I think that should be the way to go. This is what I'd usually do in the lathe, but it's a little bit of an odd shape to hold and it's a little too big for my chuck. So rather than make a faceplate, I'm just going to knock it out with the boring head. That came out as a really nice slip fit, which is not at all what I was going for, especially because there's nothing to retain the bearing in there. But, you know, goop it up like usual, and if it's a problem later, we'll fix it then. Get this oiled up real well. Made this little spacer to take up the extra, control the end play. This bearing is going to register kind of half on the unworn part and half on the worn part, so let's give it a fighting chance of staying in place. I've done a video on making a step pulley like this before, and I'll leave a link to it. And also, so I'm going to kind of gloss over some of this, but what I want to do now is turn this on a mandrel. So I made a mandrel, you can put it between centers. I need to cut a keyway in that, and I need to cut a keyway in this. I've got the right size keyway broach to broach this, but I don't have the right size bushing. So I turned up a bushing, fits in there. And now I need to cut a really deep slot in it. This is 3/16. Call it about 5 millimeters. And pretty deep. If I just come in here with a 3/16 end mill, it's going to cut it slightly oversize. Especially with the slop in my mill, it's not going to leave a nice keyway. And it will only do that up until the point where the end mill breaks. And I'm pretty sure that's going to happen. I do have one that's ground a little undersize. It would be a pretty good option to come in and just plunge along it to get most of the material out and then clean it up with that. I could try to set it up in the shaper. Slot it with a tool like this. There would be a lot of tramming to make sure the tool was plunging down straight. I also don't have a tool holder to fit this size tool, so I'd need to make one of those. Looking at the tool marks in this thing, it looks like this one was probably cut on a horizontal mill. And digging around, I found a milling cutter that actually fits on my slitting saw arbor. Looks a little dull, but I did a test cut on this, and it went right through it, so let's go for that. Now, the question of how you hold this so you get access to the side of it is one you just don't overthink too much. Well, I got this thing, no joke, 2 thousandths from the center line and hit the table. Well, that was an interesting experiment, but the belts on the mill were screaming a lot. You can tell this was getting pretty hot. So, I think we're going to try something else. I think if this cutter had been a little bit sharper to begin with, would have done okay, but didn't quite have it in it this time. I went back and checked to make sure that was centered with the edge finder, and it was off a good bit, about 20 thousandths. I'm just going to adjust the angle of this a little bit. It should be pretty good then. Still got a fair amount to remove. That's parted off. I cleaned up some of the shame on it there too. I'm going to say that was a good lesson in precision slotting, something really deep, because otherwise it was just a pain. Let's go broach this thing. Oh, one other thing I learned in the process here. B-size broach, not actually 3/16 here. It's a little over that. And the keyway for the mandrel gets the same treatment. Got the keyway in here, but I don't have a set screw in here yet. So we'll just super glue it in for now. The real advantage to doing this between centers is it just makes it a lot easier to flip it around and do features on the other side of it. You can tell this side of it goes up because it says top on it. So it turns out that's actually wrong. It's supposed to be the other way around. Don't believe everything you see on YouTube. It's a 42-inch belt. I think I might need to grab one that's a little shorter, but it's what I had on hand. It makes sense to have the nuts on this side so that you can actually adjust the motor height, belt alignment while it's on here. These nuts are the antiquated 19/32. Sometimes you find these on older machines. Of course, you don't have a 19/32 wrench, but it works out well. That works out to be right about 15 millimeters. Still got a long way to go on this thing, but for right now, I think all that's left to do is